Welcome to Beyond BIM. Today we are excited to bring to you a short series of episodes from the illustrious co-authors of a newly published book, which is titled Construction 4.0, an innovation platform for the built environment. This book best describes the Construction 4.0 in the context of its current state, emerging trends and technologies, and the people and process issues that surround the coming transformation of this sector. The book is now readily available on Amazon as Kindle or hardback. In this episode, we will discuss cyber-physical systems in construction and architecture. Joining us in today's episode is the co-author Lauren Vasey of the chapter titled Potential of Cyber-Physical Systems in Architecture and Construction. Lauren Vasey is a research associate at the Institute for Computational Design and Construction at the University of Stuttgart. Her exciting research with robotics has focused on adaptive processes with sensor-based feedback to computational processing. Her research has been recognized and awarded internationally, namely by the KUKA Innovation Award, Fast Company Innovation by Design, and AEC Hackathons. And now let's take a look at what Lauren has to say on cyber-physical systems in architecture and construction 4.0.
Usually we begin with a few words about yourself, your background, and really how you got interested in the construction and engineering sector at first place.
Okay, so I am a researcher and a postdoc in on-site digital fabrication and robotic construction here at ETH-Zurich. My background is fairly interdisciplinary, so I just completed my doctorate at the ICD, which is the Institute for Computational Design and Construction. And my doctorate was actually focusing on the potentials of cyber-physical systems in architecture and construction, so very related to the chapter that I just wrote. And previously, I had studied both architecture. I got my master's in architecture, but my undergraduate was actually in civil engineering. But the last 7 or 8 years, I really focused on sensor-based robotic fabrication and construction methods. So I really rely on my kind of diverse background to pursue this research.
That's fantastic. Okay, and in the new book entitled Construction 4.0, you in particular have discussed extensively the cyber physical systems. Can you tell us a little bit more about this and explain the concept in more depth?
Yes. So cyber-physical systems is basically a kind of concept that came or emerged from Industry 4.0, which basically just is a term for systems which basically closely couple background computational methods and networking technologies with physical processes. So in a way, it's somewhat related to different technical concepts. So in some ways, it's similar to IoT because you're using networking to connect several processes. But on the other hand, you're really leveraging data aggregation and sensor feedback to make kind of judgments about what is happening to physical processes. So these could be physical robotic processes, they could be on-site construction processes. And then you also typically in a cyber-physical system have kind of different opportunities for visualization. So in many different concepts that are presented in cyber-physical systems, there's different interfaces that enable human-in-the-loop construction or human-in-the-loop design. So how do you gather data from these physical processes? How do you post-process that into meaningful conclusions? And also display that using screens or interfaces, and also provide opportunities for interaction between people and kind of complex computational and physical processes.
Okay, that sounds very fascinating. So with that in mind, can you tell us more about how can cyberphysical systems transform the construction and architectural processes, within the wider industry?
So our industry is very peculiar because we're one of the least digitized sectors. We know this from the McKinsey reports. And also, there have been several efforts towards really enabling digitalization and robotics in architecture and construction, but none of those efforts in the past really came to fruition. So to me, the first question or the first kind of opportunity that cyberphysical systems present is really a kind of possibility of data integration. So historically in architecture and construction, we've had this issue of different building processes and software being highly compartmentalized, whereas the cyberphysical system is really about how do you connect multiple processes and pass information in real time. So to me, the first kind of shift is really thinking about how do we, instead of having silos and compartmentalized workflows, how do we pass back and forth information between design processes, between processes for verification and structural engineering, and then also physical processes where we're actually realizing the production of building components or where we're actually building structures in an on-site condition. How do we think about passing data between all of these phases fluidly?
Sure. Okay, that's great. And what would you say are the current challenges or barriers architects and contractors need to overcome before the actual cyber-physical system becomes a reality?
Well, I think there's a lot of different challenges. In addition to the kind of interoperability challenge that I was somewhat hinting at before, there's also challenges just in terms of what are the physical output devices and how do we make robots or construction equipment accessible to digital processes? So in the past, for example, all of these kind of systems were highly hermetic and didn't really offer the opportunity to get feedback from them, but also didn't offer the opportunity to kind of control them in real time. So this question of how we make these different physical actuators, robots, construction machines, how we can control them and get information back from them is a big question. In architecture also, there's several different kind of strategies that have been put in place over time to kind of as mechanisms of control. So for example, standardization is something that occurs quite frequently across materials, processes, and systems. Whereas there's a kind of fundamental paradigm shift. Instead of trying to control tolerances and to control the way things are passed from one portion of the kind of production chain to another, can we start to develop these kind of reactive and intelligent mechanisms that deal with these kind of tolerances or other issues rather than completely pre-planning everything and relying on standardization? So there's a huge new set of opportunities, but we also have to think about data transfer, interoperability, and not siloing different parts of a production and construction workflow. So with that in mind, can you further elaborate how do you expect cyber-physical systems in architecture and construction to go beyond BIM? So to me, BIM at its core is really about information and about layering metadata on a physical model, whereas cyber-physical systems, or at least also in research, it's more about establishing intelligence across multiple processes and system-level autonomy. So how do we program, for example, a robot or something that's building something with a high level goal rather than a kind of geometrically static entity? So to me, it's about really, in some cases, maintaining high levels of control through system level autonomy. So it's a higher level of kind of data processing and understanding, whereas BIM is really about information.
Right. Okay. That makes sense. It's a really nice answer. Thank you. So to move on, obviously now we've understood more about the systems and the sort of problems that it solves. How do you see it shifting the landscape of construction architecture within the next, say, 3 to 5 to 10 years?
I think that one thing that I maybe should have mentioned earlier is that innovation in this sphere is also quite slow, because I think oftentimes we are appropriating technologies from other disciplines rather than questioning what are the fundamental tools that would enable innovation in the construction sector. So this is particularly true in robotics, because the robots that we're using right now are appropriated from manufacturing. So to me, there's kind of a need for this essential R&D funding. And I think now that the McKinsey report has been released several years ago, it seems that there's more incentive in the kind of construction R&D kind of opportunities to really think what's an ideal construction robot, what are the kind of enabling technologies in terms of interfaces, in terms of software that can make these physical construction processes more manipulatable and accessible to external stakeholders in the AEC industry. And yeah, I think, and then we also have to think about what these possibilities enable in terms of new material systems. So as I said before, the building industry has really relied on standardization. And this is very true in materials. So we always try to standardize materials into highly isotropic and predictable systems so that we don't have to handle tolerances. But now there's an opportunity to use, for example, more vernacular materials that might have irregular geometric properties, or materials that are maybe more organic or natural or sustainable. So there's a huge set of possibilities in terms of design that we can really pursue now with the ability to connect physical processes with backend computational processes. So
can you tell us a little bit more about what you are planning on working next in the domain, and where can we find, and our listeners find more about what you do and keep up with the latest research?
So I would say there's two kind of questions, or maybe two fields of research. One is how we enable or enhance construction processes with sensor feedback. And this is really about how we say, give them a level of autonomy for dealing with unknowns, for dealing with tolerances, for dealing with inconsistencies, towards higher level goals that are maybe related to geometry, or maybe related to meeting certain criteria that might be performance that a building or a structure needs to meet. And on the other hand of side, I'm also interested in how these construction systems or robotic fabrication methods are also collaborative. So I think, in a sense, many different initiatives in architecture and construction have resisted automation. And that's because many different construction processes have really relied on human-level dexterity and human-level cognition. So if we try to automate everything that humans have typically done on site, I don't think it will, be successful immediately. So the question is, how do we develop systems where humans and robots and construction equipment can somewhat collaborate and work together on common construction tasks? And how do we develop new systems of safety? How do we think strategically about how they're trading tasks? How do we develop construction robots that are collaborative? So maybe not taking the exact same robot that's used in the factory, but thinking about how the kinematics would need to be adapted for the kind of scale of buildings. And really develop these kind of collaborative methods for production. I think that's a very interesting kind of question.
It does sound very interesting as well. Okay, that's fantastic.
Thank you for tuning in to listen to BeyondBIM podcast. If you enjoyed this episode and want to hear more from our latest episodes, then you can visit BeyondBIM, which is available on SoundCloud and iTunes and all the other major podcast providers.